Alrighty, folks. Starting off with our DMR, this is our first day reviewing our new skills. I'm going to do each question. Please let me know what questions or concerns you have following each response. Here we go. First up, reviewing graphs. Look at the graph below. Which subject do the kids surveyed prefer the most? I noticed that our title is favorite subjects. Our categories are math, reading, science, and social studies. And my key tells me that each pencil on this pictograph represents 2 students. So which subjects do the kids prefer the most would be the longest section of pictures, and that would show reading. Reading has 2, 4, 6, plus 1, 7 students. Reading is the most favorite subject. Questions about this graph? Good, we did pretty well on it. All right, next up. Use less than, greater than, or equal to compare. We have 2 fractions that have the same numerator. They both have 5 parts. Our denominators are different. That means we must think about the size of the pieces. We know that the greater the denominator, the smaller the piece. So 5/8 is smaller than 5/6 because 5/6 would only need to be cut into 6 pieces versus 8. So your fraction symbol should have looked, not like that, like this. 5/6 is greater than 5/8. Smaller the denominator, the larger the piece. Larger the denominator, the smaller the piece. Questions about that one? Alrighty then. Look at the fraction below. Choose all that is true about this fraction. It's Monday, guys. Sorry, I had to. Notice this is worth 2 points, which means in this case, all is more than 1, but it's only 2. Here we go. This is 1/6. 1 more unit fraction would make 1 whole. Heck no, we'd need 5 more. There are 5 pieces in this whole. Nope, our denominator is a 6. This is more than 1/2. No, we know that 1 is not half of 6. There are 6 pieces in this whole. Yes, our denominator is 6. Denominator tells us how many parts are on the whole. This is a unit fraction. Yes, unit fractions are 1 piece of a whole. Questions? Dancing? Dance break? No? Okay. All right, here we go. Next up, how much is this in dollars and cents? Dollar bills, y'all. All right, I'm going to count my dollars first. $1, $2, $3. $3. Decimal, because I'm getting ready to count the coins. I have 5 cents plus 1 is 6 cents, 7 cents, 8 cents. $3.08. And Josh Flowers, if that isn't the cutest dog I have ever seen, but I like your face more. Let me see your face. All right, $3.08. Okay. Questions, concerns, comments? Okie doke. Final question. If the dividend is divided evenly by the divisor, what is the quotient? Holy vocabulary, Batman. You have a math notebook for a reason. And we took notes in that math notebook for a reason. So if you see vocabulary that you don't know, you can use your notebook. Oh. Okay. If you remember, we showed these buckets because we know that when we're counting with larger numbers, dividing with larger numbers, we can count larger pieces. So I see that there are 4 buckets, 1, 2, 3, 4, and my number is 50. I know that there will be 10s that will fit inside of each bucket, and that's only going to be 40. So I'm going to put 10 in each bucket, and that's going to be 40. So I started with 52. I subtracted 40. That's going to give me 12 left. Okay. Now that I have 12 left, now I'm only dividing 12 by 4. 2, 3, 4. And I know that 12 divided by 4 is 4, 8, 12, 3 things. So 3 in that bucket, 3 in that bucket, 3 in that bucket, 3 in that bucket. So there are 10 plus 3 in each bucket. That is 13 items. So your quotient is 13. Remember, when we have very large dividends, we can think about larger chunks of numbers at one time. It would take us a very long time to count by 4s all the way to 52. But if I look at a larger number like a 10, now I've got a much smaller section to work with. Okay? Questions on that one? 11.
I was 2 off.
2 off. That's not bad for the first day of practice. Now we know we've just got to check to make sure each group is equal.
But then it was 13.
Yep, got to make sure each group is equal, even-sized groups. 8 and G.
For the first day, I did pretty good because I got all of them correct. For the first day.
That is wonderful. Any questions? I want questions right now. Neither of those have been questions. Questions. Leah.
I was 1 off on this one. I put 12.
Make sure they're equal because 12 times 4 would be 48. Aiden Hampton.
How is 52? Oh, now I understand.
Okay.
So 12.
Yep. All right, folks. Let's get to it. Hopping into our math for the day. Okie doke. We are going to continue on with graphing practice. Graphing practice. We're going to analyze graphs, okay? Yesterday, I was able to give you some feedback on some of those questions that you have. And then today, we're going to take a look at doing some of these together, some of these in breakout rooms, some of these independently, okay? By the time you turn this in today, it should be completely finished. Analyzing graphs, check it out. On Seesaw, click that activity, refresh your feed, click on that add response. We're going to take a look at analyzing our 3 types of graphs today. Okay. As you're pulling that up, please listen to your success criteria. Here it is.
Our learning target for today is to solve how many more and how many less problems as we analyze a graph full of data. Today we will also be using vocabulary words as we practice asking our own questions about a graph.
Okay, so looking at our vocabulary and using it to answer questions. Here is an example of using data to solve a graphing question.
This is an example of a picture graph or a pictograph. We're going to do this example together as we analyze the data and solve a problem about the graph. Our question says, how many more people like pizza and hot dogs than cheeseburgers? So as we look at our picture graph, I notice that this graph is all about favorite types of food. And most importantly, I notice the scale at the bottom tells me that each symbol is equivalent to 2 people. So I'm going to skip count by 2s as I count my symbols. Sometimes we can label our symbols to help us remember that each picture is equal to 2. My question says, how many more people like pizza and hot dogs than, There's that comparison word, cheeseburgers. So first I need to find out how many people like pizza and hot dogs combined. So I find pizza on the graph and hot dogs. I can skip count by 2 to find the total. 2, 4, 6, 8, 10, 12. 12 people like pizza and hot dogs. Now we're going to compare it to cheeseburgers. How many people like cheeseburgers? 2, 4, 6. 6 people said cheeseburgers were their favorite food. So now we're going to compare. I can tell that 12 is greater than 6, but how many more? Notice our question asked how many more prefer pizza or hot dogs. So we can count on from 6 up to 12, or we could subtract 12 minus 6. We know that 6 more people prefer pizza and hot dogs compared to cheeseburgers. Today, third grade, you're also going to be looking at a graph and asking your own question. Remember, we're going to use math vocabulary as we ask questions about a graph. We're going to start with how many more, or how many less, or how many to ask a question. My question for this graph needs to start with those question words, and I need to think about the categories that I see. I'm going to ask, how many people like chicken and pizza? That is a question I could ask another friend about this graph. How many people like chicken or pizza? I used my question words and I used categories from the graph, and I can type it into the box. How many people like chicken and pizza? This is what you're going to practice today. You're going to use your evidence in the graph to answer the question, and you will be asked to think of your own question that you could ask a friend. Good luck.
All right, let's take a look at practicing this together on slide 3. On slide 3, you will notice that it is the same graph, but a different question. Same graph, but a different question. We're going to practice this one together, okay? How many more people like cheeseburgers and hot dogs than spaghetti? Notice that word and. Remember, and when we are combining data in a graph means addition. So we are going to combine or add cheeseburger and hot dog votes and compare them to spaghetti votes. So let's take a look at our cheeseburger and hot dog votes. Count with me, please. Hot dogs are 2, 4. So there are 4 votes for hot dogs. I'm writing, you're writing. Let's take a look at cheeseburger now. 2, 4, 6. 6 people like cheeseburgers. Josh, hop on slide 3 with us, please. So we are going to combine 4 plus 6 for our cheeseburger and hot dog people. 4 plus 6 is equal to 10 people. We're comparing it to spaghetti votes. So let's take a look at spaghetti. Spaghetti has one picture. We know that one picture equals 2 people. So spaghetti has 2 votes. 2 people. Our question is, how many more? So we've now got to compare these 2 numbers that we have together. Okay? So we're going to see how many more people like cheeseburgers and hot dogs. We're taking away the people that like spaghetti to see how many extra or more are in the cheeseburger and hot dog votes. This is a very simple numerical equation of 10 subtract 2. We know that that equals 8. 10 subtract 2 equals 8 people. Like cheeseburgers and hot dogs more than spaghetti. So 8 people like cheeseburgers and hot dogs more than spaghetti. Right now, as you are waiting, after you finish up, I want you to think about a question that you could ask. I'm going to call on a few of you to unmute and share a question. Think of your own question that you could write about this graph. Look at the data here. Think about a question you could ask. Okay, as you're finishing typing, Leah, what question could we ask about this data?
How many more people like pizza than chicken?
All right, let's see if that makes sense. Pizza has 4 pictures, chicken has no pictures, so do more people like pizza? Yep, so we'd be able to solve math there. Awesome. What other question could we ask about the data in this graph? Sing Q.
How many more people like hamburgers than hot dogs?
All right, let's see if that makes sense. Our cheeseburger total is all the way up here with 3 pictures. Hot dog is shorter with 2. So yes, more people like cheeseburgers. So how many more like cheeseburgers than hot dogs? Would be a math equation we could solve. 8 and G, what question could we ask?
We asked how many is all together.
Ooh, how many people voted all together in this data? So we can look at all of the pictures and we could count by our 2s to see how many people voted. Excellent. All right. You are getting ready to go into a breakout room to solve slide 4. Okay, breakout room to solve slide 4. Slide 4 is the only slide you are going to solve in your breakout rooms. Okie doke. Here come you. Here is what you should have found. How many people liked spaghetti or pizza? Or is another word that means combining, because it's saying, would you like this or this? They're both in my hands. You get to choose. Okay, so putting them both together. Miss Sousa, these numbers are so easy. You're right, guys, because we're not focusing on your addition skills. We're focusing on your ability to understand and read the graphs, okay? So you're looking at the data from the graphs, all right? Any questions about why this is the correct answer? Will.i.am.
I couldn't hear Christopher. It wouldn't let him unmute.
Strange. Okay, it should next time. All right. You are going to skip slide 5 You are going to skip slide 6. You are going to slide 7. I'm going to check screens, skip slide 5, skip slide 6, hop to 7, 1, 2, 3, 4, 1, 2, 3, 4. Guys, I'm going to play that cheeseburger song for you. It's going to change your life. All right, slide 7. I'm going to play this. You are going to listen. Here we go. Listen to the song that's in my heart. Here it is.
This is an example of a bar graph. I notice this bar graph is talking about favorite seasons, and we have 4 categories, which are our 4 seasons in a temperate climate. I also notice the scale to the left. I notice it starts with 4, it starts with 0, goes to 4, but I notice this line right here. I notice these lines in between. So if I'm going to count, I know that I'm counting actually by 2s because 2 plus 2 is 4. So my scale is 2 for this graph. My question says, how many less students said spring was the best season than summer? So again, I'm noticing my question words, how many less? Then I'm comparing 2 sets of data on the graph. Then I can look at my categories, spring and summer. So let's identify those on the graph. Here's spring. So counting by 2s, I see spring has 16 students who voted for spring. And my next is summer. Here's summer on the graph. Summer goes, wow, all the way to the top. 20 students said summer is the best. So this than word tells me I'm comparing these two. By looking at the graph and using my background knowledge, I know that 20 is greater than 16. But my question wants to know by how much. How much is in between 16 and 20? A couple different strategies you can try. You can mark off where spring ends and then count on up to 20. You can use the graph to help you, or you could count on from 16 up to 20. Or you can subtract starting with the greater value. 20 subtract 16, we know the difference is 4. 4 less students said spring was the best season than summer. So 4 less students. Great work. Today we are also practicing asking our own questions about the graph. When we ask a question about the graph, we need to use our question words like how many more, or how many less. For this graph, I'm considering a question that would be a good, interesting question to ask a friend using the vocabulary from the graph. I'm thinking I'm going to ask, how many, I think I'm curious about winter. How many students voted for winter? This seems like a question that I could answer myself or another classmate could answer, because I can go to the graph and find out how many students voted for winter. I can determine that using my data. Now it's your turn to try with a bar graph. You're going to use the data to answer questions and think of a question you could ask about the data.
All righty, same skill, different graph. Okay, same skill, different graph. Hop on slide 8. Slide to the 8. Slide to the 8. All right, here we go. Our question is here. How many more, there's our vocabulary, students chose winter and spring than summer? So first, we've got to combine winter and spring. So let's check it out. Miss Renalea already showed us spring is at 16. I can see that on the graph because it's right next to the 16. Now we've got to count winter. My real scale is going by 4s. So I know that I have 4, 8, but look, I can't go all the way up to the next hop. So I've got to add half of my scale, which is 2. So this is 4, this section is 4, this section is 2. So 4 plus 2 is equal to 10. 10 students voted for winter. Okay? So let's check this out. Winter plus spring is 16 plus 10, and that gives me 26 votes for winter and spring. I'm writing, you're writing. Josh, I'm writing, you're writing. Slide 8. All right, now we're comparing summer. Summer is all the way up here at the top. We can see that that is up to 20. So 20 people voted for summer. Our question is, how many more students chose winter and spring than summer? So I can do this one of 2 ways. I can start at 20 and count up to 26. 20, 21, 22, 23, 24, 25, 26. That was 6 more people. So 6 more people. I gave y'all a little bit of grace on the last 2 assignments without your labels. Okay? It is now time for you to make sure you have your labels. If you do not have your labels, you are wrong. 6 more people chose. Boop, come on, UE, there we go. Spring and winter than summer. I'm writing a little bit of a shorthand there. So 6 more people chose spring and winter than chose summer. So that was adding up. I could also do it by subtracting if that makes more sense for me. 26 minus 20 is 26, 25, 24, 23, 22, 21, 20. Minus 6 gave us 20. Same answer, 2 different ways to solve. Okay? As you are writing and finishing up, I want you to think about what question you could ask about this graph. What is a question that you could ask about the data in this graph? Terrence, what question could we ask?
It's not about that. Can you go back to slide 6?
Not right now, because we're skipping slide 6. What question can we ask about the graph on slide 8, the data here? Levin, give me a question about slide 8. About the data here. What could we ask?
We can ask, what is that? What is the other way of 16 plus 10? 16 plus 10.
What do you mean by what is the other way of 16 plus 10?
Like, you know, like when we're doing, I forgot what that's called.
So I'm asking you about the data in the graph. So we want to ask graphing questions like how many more or how many less or how many. What's a question we could do like that?
We would want to ask, what are the scale counting by?
Okay, what is our scale counting by on our graph? That would be a good question about this data here. Thank you. Leah.
What season did 20 people vote on?
Giving the answer and looking for the category. Which season has 20 votes? We'd have to look and see which season has that. Great, fantastic. All right, I want you to check out slide 9, please. Slide 9. How many less students said winter was their favorite season than spring? So how many people said winter was their favorite season than spring? Okay, you're getting ready to solve this in your breakout room. Here's your correct answer. How many less students said winter was their favorite season than spring? Spring has 16 votes. Winter has 10. 16 subtract 10 is equal to 6. The 6 represents the less students saying winter is their favorite over spring. All right. And skip. Slide 10. Skip. Slide 11. Go to slide 12. Skip 10, skip 11, slide 12. I am going to play the video. You are going to watch and listen.
This is an example of a line plot graph or a scatter plot. I'm excited about this one because I notice the title is all about candy, and I love me some Halloween candy. I also notice that this does not specifically say a key. When a graph does not give you a key, that means that each symbol is equal to 1. So sometimes in 3rd grade, we might notice that the scale is 1, just like on this example. So each x is equal to 1. We're going to use that information to help us answer this question over to the right. Our question says, how many more people got 54 pieces than 61 pieces of candy? Okay, I'm noticing some comparing language. I'm noticing my question words, how many more? Then I'm noticing this word than. I'm going to compare 54 pieces of candy and 61 on the graph. So let's find 54. Here it is. I'm going to count up the total of pieces of candy. Let's see how many people got that. 1, 2, 3, 4, 5, 6 people. 6 people got 54 pieces of candy on Halloween. My next instruction is to check 61. Let's find that on the line plot. Here is 61. How many kids got 61? 1, 2, 3. There are 3 X's. So 3 students got 61 pieces of candy on Halloween. Okay, my question says how many more got 54? I can see that 54 has more students. Look how tall these X's go compared to 61. But my question says how many more? I can look at where they are equal on the graph. They both have 3 students. And then I can check out how many X's are extra, how many more X's there are. Or I can subtract 6 students minus 3 students. We get a difference of 3. So there are 3 more people who received 54 pieces of candy compared to 61 pieces of candy. Awesome job. Now I want you to be thinking of a question you could ask about this line plot graph. Remember, you need to use words like how many more, or how many less. What could we ask about this graph? I'm thinking of a question that I could ask another classmate. It needs to be a question that I can answer myself using the data on the graph. So I'm thinking of a really tricky question. I'm wondering how many students, how many people got between 50 and 60 pieces of candy? I'm wondering how many people got between 50 and 60 pieces of candy. I wonder if somebody can use the line plot and figure that out. So I'm going to record my question using my vocabulary. How many people got between 50 and 60 pieces? I bet you another third grader could look at this line plot and answer this question using their data.
Okay, let's take a look at slide 13 together. We have our vocabulary here. How many more people got 59 candies than 52? So we're going to find 59 on the graph. We're going to find 52 on the graph. 59 is right here. I can see that there are 1, 2, 3, 4 X's on 59. So 4 kids got 59 pieces of candy. I'm writing, you're writing. Let's look at 52. Here is 52. 1, 2 X's. 2 people got 52. Miss Sousa, 4 minus 2, that's so easy. You're right, but we're not focusing on your skills for addition and subtraction. I'm focusing on, can you find the data and answer it, okay? So we're going to compare the 4 X's to the 2 X's. 4 minus 2 is, of course, 2, but it's not 2 purple unicorns flying through space. It's 2 more people got 59 candies than 52. Okay. So again, on line plots, these down here are our categories. These are not the data numbers. Okay, this is how many people have a certain amount. This is the amount here. The X's are the number of people. Okay. All right. Your independent work are the slides that we skipped and the slides down here that we didn't skip because we didn't get to them yet. Okay. So you have 2 slides about pictographs, slides 5 and 6. You have 2 slides about bar graphs, slides 10 and 11. And you have 3 slides about line plots, 14, 15, and 16. Okay? So when you click this green check today, every single slide should be done. All right? So 2 slides about bar graphs, 2 slides about pictographs, 3 slides about line plots, and as always, your success criteria. That is your assignment for today.